Second question on electromagnetic field transformer, question number 2. Let's look at this. A circuit has an area of 0.4 meters squared and consists of 50 loops of wire, full stop. If the loops are twisted and allowed to rotate at a constant angular velocity of 10 radian per second in a uniform magnetic field of 0.4 Tesla, the amplitude of the induced voltage is dash. Alright, this is very simple but demands some kind of analysis so that one would not run into some kind of confusion. So the first thing we need to do is we demonstrate this. Let's just demonstrate. A coil, right? A circuit has an area of this. Okay, if that is the case, if we say this is the coil, all right, okay, and there's something like this, let's just take this to be something we represent. We have this all through, okay, number of turns. Okay, if this represent the area A, cross-sectional area A, right? Okay, or rather we take something like this. If we take something like this, first one, second one, and third one, maybe this represents a cross-sectional area of the core A. The same thing here, A, right? So we are talking about 50 loops. Maybe we run this 1, 2, 3, 4 until we have 50 loops. But the area is 0.4. That means this cross-sectional area is simply 0.4 meters squared. Number of turns, loops that we have is simply what? 50 loops. Correct. What next? There is something we need to take note of. The angular velocity. The angle, each time it turns, an angle is swept across. So the angular velocity is 10 radian per second. And that is, maybe this is the center. If you take the radius somewhere, the angular here we're talking about. Okay, so W is equal to 10 radian per second. Take notes. What next? We are talking about uniform magnetic field. Okay, the coil has some magnetic flux around it, very tiny magnetic flux, which cannot be seen with our ordinary naked eyes. We can see this with some high-rated instruments, okay? And that magnetic field is of value 0.4. Magnetic field is B is equal to 0.4 Tesla. So let's bring out all these things as our data now. Our data, well, we call it parameter. Let's start. The first one is A, which is 0.4 meters squared. The second one is consists of loops. Okay, that should be number of coils or turns. N is equal to 50 loops. 50 loops. Either we call it 50 loops or we call it 50 turns. All the same. Then we have angular velocity, W or omega is given as 10 rad per second. And then magnetic field, the magnetic field of such a coil or around such a coil is B equal to 0.4 Tesla. Good. What are we looking for? We are looking for the amplitude of the induced voltage. The amplitude, okay, the amplitude of the induced voltage. Very, very technical. We need to state something that represents that, and that is E is equal to E naught sine omega t. Alright? The amplitude of the induced voltage is E naught. And then E naught is given as N, A, B, and W. So with this, we can find the amplitude of the induced voltage. So what next are we supposed to do? We wisely substitute according to these letters we have, N, A, B, and W, where we have these letters represented accordingly. So that's the next thing. Let's see this side. Let's see how it plays out this side quickly. Alright, so what we need to do, we are calculating the induced voltage, E naught. So let's go. E naught is equal to, let's just repeat what we have, N, A, B, and omega. Take enough space. E naught, enough space, E naught is equal to, for N, we have how many? 50 loops. So we have 50 for N. For area, we have 0.4. 0.4. 0.4. And then what next? For magnetic flux, we have 0.4 again. We need enough space here. Enough space. So E naught is equal to 200 times 0.4 times 0.4 times 10. Good. Okay. So what we need to do for us to get this right is we take this. E naught is equal to 200. This is 0.4. This is also 0.4 at this point. And 0.4 times 10 all over that. Okay. Okay. There is a mix-up. Our N is 50, not 200. That's good. Our N is 50, not 200. I mistakenly wrote 50, okay? Alright, so I think this is a bit tight up. And E naught is equal to 50 times 0.4 times 0.4 times 10. That's correct, right? That is it. So we have this. Let's look at it very well. We have represented all that using those letters. The next thing we need to do, suppose we want to solve without a calculator. We can do that quickly. We maintain or induce the amplitude of the voltage. So we have E naught is equal to, for this is 50. For this, we convert this to 4 all over 10. The same thing here, 4 all over 10. And then 10 all over what? 1. This can also be 1. That's it. I hope we are not missing up anything. So 10 cancels 10. That's what it means. 10 here, we take care of this 10. And then 0 here, we take care of this 0. We are left with E naught. Let's bring out what we are left with. 5, 4, and 4. 5 times what? 4 times 4. And this will give us 5 times 4 is 20. 20 times 4 is 80 volts. Therefore, the induced voltage is 80 volts. Solved. It's been solved. It has been solved. So what we need to do now, we go through the steps one at a time and then find out if there is anything we missed in the first place. But if there's nothing we have missed, it means the answer is 80 volts. We come here and write 80 volts. Simple. However, if you think otherwise, my dear, come on, put it in the comment section. We discuss it further from there. See you in my next class. Come on. All right, I'm done for today.